To keep yourself updated, subscribe to Indigo Learn and click the bell icon.
So today we are going to discuss very interesting topic which is most useful in our day-to-day life, that is the concept of permutations and combinations. So if you are wondering how to differentiate between permutations and combinations and what is the easy way to learn what is a permutation and what is a combination, so today you are going to get good understanding of these topics. Okay. So before we get into that, let me ask you a simple question. Okay. So let us say we have 3 seats to be filled, right, and we have 3 people. Let us say we have A, B and C and we have to fill 3 seats. Okay. Now if I ask you, in how many different ways can you fill these 3 seats using the people A, B and C, right? So you might be wondering, how do I fill the 3 seats with A, B, C? Is the order in which I fill A, B, C, is it important? You have to ask yourself whether A, B, C and A, C, B are the same or the different. Similarly, when you fill B, A, C and B, C, A are the same or the different. Similarly, when you fill C, A, B and C, B, A are the same or the different. So if your answer is they are different, then by default you understand that arrangement is extremely dependent on the order in which you place people in a row. Or in other words, whenever we are discussing about the concept of permutation, we are discussing about what we call as an arrangement. So in arrangement, what is extremely critical is the order in which you place people in this row, right? So if to summarize all the different arrangements I have told you, let us say we have 3 different seats available and you have A, B, C who wants to sit in these places. In how many different ways can A, B, C get seated in these 3 seats? So if I try to arrange them in different possible combinations, you would have observed I told you A, B and C, then A, C and B, then B, A and C, then I said B, C and A, then finally C, A and B, then C, B and A. So if you see that I started with fixing A in the first position, then I tried to change B and C and I did the same way for the other 2 also. If you have identified, totally there were 6 different ways in which I could arrange it. Now arranging 3 people was easier because I could count them. What if I have to arrange large number of people in a row? Now how do I do it? So you also understand manual counting of such a big problem is not possible. Now we have to find a way to understand the concept without manually counting it, right? So here we understand the concept of factorial, or we use the formula for permutation. So the notation N, P and R, right? So N, P, R, that is a notation which we are going to learn, and we are also going to learn what is the concept of factorial. Okay, so first let us try to understand what is a factorial, right? Factorial of a number is nothing but you multiply the number in the decreasing order till you get 1. For example, if I have the value 3 factorial, right? You start by multiplying 3 with the number that comes before 3, that means 1 less than 3, which is 2. Then you multiply with a number which is 1 less than 2, which is 1. You keep multiplying till you get 1. Or in other words, if I want to learn what is the value of 3 factorial, I have to do 3 into 2 into 1, which will give you the value 6. So similarly, if I am going to ask you what is the value of 4 factorial? Yes, so your answer will be 4 into 3 into 2 into 1, which will give you how much? 24. Similarly, if I am going to ask you what is the value of 5 factorial, right? Yes, so 5 into 4 into 3 into 2 into 1, which will give you 120. So if I am going to ask you what is the value of n factorial, how do you write it? Because unless I know the value of n, I will not be able to tell what is the value, but at least notation wise, if I am trying to understand what is n factorial, you can write n factorial is nothing but n into 1 less than n will be n minus 1, 1 less than n minus 1 will be n minus 2, and so on dot 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 till we get the final value as 1, right? So the notation for factorial is nothing but you keep multiplying the number with in a decreasing order, like 1 less, till you get 1 and you multiply all the values. This is what we have as a factorial. Now coming back to our question, now I have 3 different positions and I have 3 people A, B and C who wants to sit in these positions. Now let us take with the first position from here, okay. Now in this position, who all can sit, right? So in this position, either you can arrange A or you can arrange B or you can arrange C, because if you want to start by arranging, you can arrange any one of your choice, right? So if I want to fill this first position, I can fill it in 3 different ways. Which are the 3 ways? I can fill it with A, I can fill it with B, I can fill it with C. So the first position can be filled with 3 ways. Now coming to the second position or the middle position. Now that first position is already filled by someone, it can be A or B or C. The middle position or the second position can be filled by how many people? It can be filled by only 2 people, or you can fill it in 2 ways because the first position is already occupied by someone. Now that the second position or the middle position is already filled, in how many ways can you fill the last position or the third position, which is only 1 by default. Now the first position can be filled in 3 ways, the second position can be filled in 2 ways and the third position can be filled in 1 way. In other words, the entire arrangement can be done in 3 into 2 into 1, which is 6 ways, which is the answer that we got, 6 different arrangements. Now this process of multiplying 3 into 2 into 1 is called multiplication rule. So in permutations, this multiplication rule is very important because you are completing the problem by arranging the first position, arranging second position and arranging third position. Finally, if you want the total number of arrangements, you multiply the first value with the second value with the third value to derive the total number of arrangements, right? So let me ask you a simple question now, right? Let us say we have to select middle order for the Indian cricket team for the upcoming World Cup, right? We already know the openers Rohit Sharma and Shikhar Dhawan is already finalized more or less. Now in the first position, that means in the first down, we have Virat Kohli who is also finalized. Now let us say second down, third down and the fourth down is extremely critical positions for the team and we have contenders for these 3 positions. Let us say the contenders are Dhoni, right? The contenders are Kedar Jadhav and let us say the contenders are Dinesh Karthik, right? So second down, third down and fourth down have to be filled and you have 3 different people available, right? Now if I ask you in how many ways can I fill these positions, that is second down, third down and fourth down using these 3 cricketers, now if what will be your answer, right? Now I did not specify you who should come in the second down or who should be in the third down or who should be in the fourth down. That decision will be taken by the team management depending on the situation of the game. Assuming that the initial players play really well, then you might have Dhoni coming in the second down to hit the ball out of the park very early, right? Or in case the wickets fall very fast, probably they would send Kedar Jadhav and probably preserve Dhoni towards the end. Now in this case, now I have to fill the second down, third down and fourth down with these 3 people. How many ways can I do it? Now you also realize the order in which you put these people is extremely critical. So wherever you sense the order of arrangement is extremely important, these 3 positions have to be filled by these 3 people. So the number of ways in which I can do it is 3 factorial, or in other words we also call it as 3p3, right? Now I started using one more notation called NPR, right? What is NPR? NPR is nothing but arranging R objects in n places. So in this case, the number of places available are 3. The number of people I have to arrange are also 3. So I have to arrange 3 people in 3 places. So number of ways I can do it is 3p3 or 3 factorial. We already know how to compute the value of 3 factorial, which is 6. Now let us try to understand how do we compute the value of 3p3. Okay, let me write down and show it to you. So the notation for NPR is nothing but n factorial by n minus r whole factorial. So if you recall guys, I am writing it as whole factorial. So n minus r should come in the brackets, correct? Now if you see, I want to compute what is the value of 3p3. So numerator will be 3 factorial, denominator will be 3 minus 3 whole factorial, or in other words, you have 3 factorial by 0 factorial. So now what is the value of 0 factorial? 0 factorial by default is 1. You already know what is the value of 3 factorial, which is 6. So final outcome is 6, right? So this is one way to solve the problem. If you choose to do it directly using the concept of 3 factorial by saying that the second down can be filled by any of these 3 people, the third down can be filled by any 2, and the fourth down has to be filled by the last remaining person, you can say the number of arrangements are nothing but 3 into 2 into 1, which is nothing but 6. So that also will give you the same answer. So to summarize whatever we have discussed, whenever we are discussing the concept of permutation, we are always referring to what we call as arrangements, and the order in which people are arranged is extremely critical, right? So this is where we are going to understand the critical difference between permutation and combination. So now that we have understood the basic representation of what we call as a permutation, let us try to understand in detail where all permutation related concepts are used, and even if I don't mention the word permutation, how do you know that you have to use it, right? So let me give you a couple of examples, okay? So now I want to frame a 3-digit number, correct? I want to form a 3-digit number using 1, 2 and 3. So the options that I am giving you are 3 options, that is I have to frame a 3-digit number using only 1, 2 and 3. Now try to write down what are the different 3-digit numbers that you can frame using only 1, 2 and 3. So try doing it. So some of you would automatically think, or on the top of your mind, you would already get different ways of arranging these numbers 1, 2, 3 in 3 different positions, because I want to form a 3-digit number. So if your answer is, sir, 123, then 132, then 213, then 231, then 312, then 321, then your answer is exactly correct, right? So you followed the exact same principle that we tried to do when we were arranging A, B, C in 3 different positions. So here also you understand the place value of the 1, 2 and 3 are extremely important. So 123 and 132 are completely different numbers. Similarly, 213 and 231 are also completely different numbers. Similarly, 312 and 321 are also completely different numbers, right? So here, though I did not mention you to use permutations, by the concept of understanding that order of arrangements are extremely important, you yourself would have done 3 into 2 into 1, or you would have applied 3p3, or you would have already said 3 factorial, correct, right? So let us try to extend this logic with one more example, correct? Now I want to form a 3-digit number again, okay, but you have all available numbers at your disposal. That means how many numbers are available to you which are unique? You have all numbers from 0, 1, 2, 3, 4, 5 and so on up to 9. Or in other words, you have 10 different numbers available to you to form a 3-digit number, right? So remember the word 3-digit number. So you have 10 different options available to you to form a 3-digit number. Now if I ask you how many ways can you do it? Now you are wondering, how do I do it? You have 10 different people or 10 different numbers trying to occupy 3 different positions, which are units place, tens place and hundreds place. Now if you are trying to put it, one disclaimer or one star mark which say conditions apply is, please don't put 0 in the hundreds place. Why should I not do it? Because you all understand, the moment 0 comes in the hundreds place, instead of it becoming a 3-digit number, it will become only a 2-digit number. So, I have to be little careful. So, let us try to understand one thing at a time, correct? Okay. So, let us look at units place, tens place, hundreds place. Now, let us start with hundreds place. So, if you are wondering, sir, why should I start with only hundreds place? Because that is the most significant digit where 0 cannot be used. So, let us try to fill that position first, okay? Units place, tens place and hundreds place. So, you tell me guys, in how many ways can I fill the hundreds place? Can I do it in all 10 ways? That means, in other words, I am asking you, if I want to fill the hundreds position, can I use any number from 0 to 9 or do I have any restriction? If your answer is yes sir, I have a restriction because I cannot use 0 in the hundreds position, your approach is perfectly correct, right? Or in other words, you can use any number from 1 to 9 but not 0. That means 0 can't be used. So, the hundreds position can be filled in 9 different ways. Which are the 9 different ways? You can use any number from 1 to 9, right? Now, coming to the tens position. Now, before we understand this, some people also ask or have a doubt, can I repeat the numbers or I cannot repeat the numbers? Yes, your thinking is on the perfect direction because we have two different cases. So, let us assume in this case that we will not repeat any number, okay, right? We will also understand how do we approach the number if I want to repeat it, okay. So, first let us assume there is no repetition. Now, coming back. So, how many ways did I fill the hundreds place? 9 ways. So, which are the 9 numbers that you can use? Any number from 1 to 9. Now, coming to the tens position guys, right? Now, my question is, can I put 0 in the tens position? Yes, why not? Because the moment hundreds position is filled with a non-zero number, it will automatically become a 3-digit number, because even if 0 comes in the tens position, it will not alter your 3-digit number. It will still become a 3-digit. It will not become a 2-digit. Now tell me, in how many ways can I fill the tens position? Yes. So remember, from 1 to 9, you have already used any one number to fill your hundreds position, correct? So out of 1 to 9, you have 8 numbers available with you, and the 0 also gets added to this bucket. So total number of options that you have now to fill the tens position is 9 different options, right? Why again 9 came? Because in addition to these 8 different numbers, you also have 0 which got added to your choice. So this becomes 9 different ways. Now coming to the units place. How many ways can you fill the units place? Already we have 9 now. Out of this one number you would have already used for tens place. Now the number of options available to you are 8. So hundreds place can be filled in 9 ways excluding 0. Tens place can be filled in 9 ways including 0, and units place can be filled in 8 ways while reducing the choice. So number of ways in which I can form a 3-digit number without repetition using the digits 0 to 9 is nothing but 9 into 9 into 8, right, which is 9 into 9, 81, 81 into 8, which is 648. Now, I ask you the same question guys. Now, what if I allow you to repeat the numbers? Will your answer change in this case? If your answer is yes, let us see how is that possible. Now, you have to still follow the same process of not using 0 in the hundreds place. Only additional flexibility you have is that if a number is used, you can choose to repeat the number again, correct? So, let us see how the answer is going to change if I can repeat the numbers. Now coming back to the hundreds position again, which is the most significant position. Now I am asking you, how many ways can you fill the hundreds position? 9 ways, because you can't use a 0 here, right? Now coming to the tens position. How many ways can you fill the tens position? Will it be 9 or will it be 10? Yeah. So in the previous example, we have considered 9, Because a number which is already placed in a hundreds position cannot be used for a units position. Whereas when we can repeat the numbers, in addition to 0, you also have the number which you have already used that you can use again. Or in other words, hundreds position can be filled in 9 ways, whereas tens position can be filled in 10 ways, because you can choose to repeat the number along with 0 also. Now coming to the units position. How many ways can you fill the units position? This will also be 10, because you can choose to use any number from 0 to 9. Or in other words, if I want to know how many 3-digit numbers are possible using the digits 0, 1, 2, so on up to 9, where repetition is allowed, it is 9 into 10 into 10, which will give you 900. So if you try to count, 100 is the first 3-digit number, 999 is the last 3-digit number. If you try to count from 100, 101, 102 and so on up to 999, how many such 3-digit numbers are available, you will exactly find out there are 900 3-digit numbers, right? So you see, instead of counting all the numbers, we found out how many 3-digit number possible in a very short form. Now you ask me, sir, what did we do in the previous case? Why did we get 648 there? Because their repetition was not allowed. Or in other words, I am not counting numbers like 222, 333, 444 and so on, and also I am not counting numbers like 331, 311, 424 like that, where a number can be repeated more than one time, correct? If I exclude all the numbers where at least one number is repeated, I will find out only unique numbers, which are 648, right? So always remember, when you are trying to arrange possibilities where you are dealing with numbers, always watch out whether repetition is allowed or repetition is not allowed, correct? Now I am going to ask you a very simple question, okay? Now I want to form a 4-digit number using numbers 0 to 9 where repetition is allowed. I want to form a 4-digit number using the digits 0 to 9 where repetition is allowed. Now tell me, how many ways can I do it? Yes, if your answer is 9000, you are spot on, because the thousands place can be filled in 9 ways, hundreds place 10 ways, tens place 10 ways and units place also 10 ways. So 9 into 10 into 10 into 10 will give you 9000. The same question, if I ask you repetition is not allowed, what will you do? You will follow the same logic that we followed when we dealt with a 3-digit number. What will you do? Thousands place can be filled in how many ways? 9 ways. Hundreds place can be filled in how many ways? 9 ways, because that number that you have used in thousands position cannot be used for hundreds position, and you also have 0 getting added. So number of options will remain 10. Originally you have 9, then minus 1 and plus 1, because one number gets subtracted, 0 gets added. So number of ways in which you can fill tens, thousands position 9, hundreds position 9, tens position 8, units position 7. So 9 into 9 into 8 into 7, whatever is that answer. Agreed? So whenever you are dealing with numbers where the place value is extremely critical, or whenever you are dealing with arranging people where the position in which they sit is also critical, there we go using the concept of permutation, or we generally use the concept of factorial to arrive at the answer. Now let me ask you one more question, okay? Let us say I have a word square, okay? SQUARE is the spelling for square. Now if I am asking you a question, how many different words can be formed using the letters of the word square, right? Again I am correctly specifying SQUARE. So let us say I have 6 different words. You see, none of the alphabets are repeating. Now I will refine my question and say, how many 6-letter words, how many different 6-letter words can be formed using SQUARE? So try to relate this concept to what we discussed about arranging people. Now a simple question. SQUARE, SQUAER, are they same or are they different? If your answer is they are different, then you understand this is nothing but arrangement, correct? Because the place where you put the alphabet changes the meaning if it exists, or it will completely change the word itself, correct? Or in other words, what I am trying to ask you is, I have 6 different positions and I want you to fill those 6 different positions with 6 different alphabets, which is SQUARE. You see, there is no repetition here. That means there is no word, no alphabet is repeating more than one time. So it's as simple as filling 6 different chairs with 6 different people. I have 6 chairs, I have to fill with 6 different people. Number of ways I can do it, straight away you can say the answer is 6p6, or you can say 6 factorial, or you can say 6 into 5 into 4 into 3 into 2 into 1. So automatically in all 3 cases you got the answer as 6 factorial, which is 720, right? So these are all the very basic ways to understand the concept of permutation or arrangement. So just to summarize, whenever you are trying to arrange people, whenever you are trying to create different numbers, or whenever you are trying to create different words where the order in which you place a number, the order in which you seat a person, the order in which you put an alphabet is important, we basically understand indirectly that it is a permutation. So you can choose to use the concept of multiplication rule, or you can choose to use the concept of NPR to get your answer. So now let us try to understand more examples with respect to arrangement of alphabets or arrangement of numbers. Okay. Now my first question is, in how many different ways can you arrange the letters of the word computer, right? COMPUTER. So if you have seen, none of the alphabets are repeating and you have 8 unique alphabets. Now if my question is, in how many different ways can you arrange the letters of the word computer, then effectively I am asking you to take 8 different seats and try to arrange these 8 different people in those seats. How many ways can you do it? So your answer automatically by now would be 8 factorial, or 8p8, or 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, right? Now let me twist the question a little and try to see whether you spot the very basic difference, right? In how many different ways can you rearrange the letters of the word computer? So did you spot the difference between the previous question and this question? So in the previous question I asked you how many ways can you arrange the letters of the word computer. Now I am asking you, in how many ways can you rearrange the letters of the word computer? So effectively my approach to this question is not going to change. I am still going to go ahead with arranging 8 different alphabets in 8 positions. So still I am going to say the value is 8 factorial only, but since the word rearranged is given, so I should not count what is the arrangement that is already given. The arrangement that already given is computer. Computer is an arrangement that is already given. Since using the word rearrangement, whatever is the value of 8 factorial, which is 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, which comes down to 40320, from that value you have to subtract 1, because I am using the word rearrangement. That means you should not take computer, which is already an arrangement, again in your answer. So effectively it becomes 40319. So that's the basic difference, guys, and we have to be very careful whether he is using the word arrangement or whether he is using the word rearrangement when he is actually trying to ask you the question. Okay. Now my fundamental question is, whenever we have the notation NPR, what are the rules that we need to follow to use NPR. Now I am going to ask you guys, what is the value of 5p2? So to solve this formula, you should know how to denote the value of NPR. So in the initial part of the class, I explained you NPR formula is nothing but n factorial by n minus r whole factorial, right? So if I am using 5p2, what will be your derivation of the formula? Numerator will be 5 factorial, denominator will be 5 minus 2 whole factorial, which is 3 factorial. Or in other words, numerator is 5 into 4 into 3 into 2 into 1. Denominator will be 3 into 2 into 1, where 3 into 2 into 1 will get cancelled and you are left with 5 into 4, which is 20. Or in other words, if I have 2 positions to be filled and I have 5 different people trying to sit in those 2 positions, number of ways in which I can arrange 5 people in 2 different positions is nothing but 5p2, which is nothing but 20. So you can just manually check how this 20 is possible, correct? Now in this question, is it possible that there are 5 different positions and you have to fill it only with 2 people? Or in other words, is 2p5 possible? No, technically, because if 5 positions are available, how can you fill only 2 people so that you occupy everything? Technically it is not possible, because 5 positions have to be filled, means minimum you require 5 people, correct? You can have more than 5 people, you can choose to pick 5 out of them and arrange them, but technically if I have only 2 people and I have to fill 5 positions, which is not possible. Or in other words, whenever I use the notation NPR, always remember n is either greater than r or n is equal to r. So n can never be less than r. Or in other words, I can find out what is the value of 5p2, I can find out what is the value of 5p5, but I can never find out what is the value of 2p5 or 3p5 or even 4p5 to that matter. Agreed? So the first basic rule whenever we are using the formula NPR is n is always greater than or equal to r. We have tried to arrange the letters of the word. Now obviously it's a very plain question. Now more often than not, they will try to ask you questions where he will say, in this word I want this particular alphabets to be together. Or I can also say this particular alphabets should never be together. So these are the kind of different variations you also need to learn to master the concept of permutation. Okay. So let me give you a very basic question that you can think of. Let us say I want to arrange 3 boys and 3 girls in a row. I have 3 boys and I have 3 girls and I have to arrange them in a row. So my question is, in how many ways can you do it? I have to arrange 3 boys and 3 girls. Now you are about to think, is there any special arrangement that you have to make, or you can arrange boys and girls in any order that you want? Since I did not specify any choice from my end, which it automatically indicates you can arrange them in any order that you want. So here the gender, whether it's a male or a female, becomes irrelevant, because you are trying to arrange 3 boys and 3 girls in a row. Effectively it is as good as asking arrange 6 people in a row. You already know how many ways can you arrange 6 people in a row, which is 6 factorial. Or in other words, if you want to arrange n people in a row, the formula is n factorial, assuming there are no conditions. Now let me make this problem interesting. Okay. Now I am asking you, arrange 3 boys and 3 girls in a row such that no 2 girls sit together. That means you don't want girls so sit together. Now start thinking, how is it possible that girls do not sit together? If you try to visualize this question, you will realize that if girls should not sit together, they have to sit between boys. Agreed? Now then, since boys have to be arranged first because girls have to sit between them, so first my question is, how many ways can you arrange 3 boys in a row? how many ways can you arrange 3 boys in a row? Which is 3 factorial, right? So let me show you the notation. Let us say we have B1, B2, B3, G1, G2, G3. Guys, remember, whenever we are dealing with people, everyone is unique. It's not like we are picking balls, right? When we are picking balls, obviously all the balls look same size and shape. So obviously the importance attached to each ball is the same. Whereas here, since we are dealing with people, you have to be very clear that arrangement, you are getting multiple answers only because everyone is unique. Okay, now let's proceed. 1, 2, 3, 4, 5, 6, guys. So 6 positions are there. Initial case, no issues. So you can arrange boys and girls in any order, previous example. So 6 factorial, correct? Now my question is, no 2 girls sit together, right? Now if no 2 girls have to sit together, what you will do, right? Now first we have to arrange boys, right? Boys can be arranged in 3 ways. So it can be B1, B2, B3, B1, B3, B2, B2, B1, B3, B2, B3, B1, B3, B1, B2, B3, B2, B1. It's like arranging 3 people in a row, 3 factorial. Now that you have arranged boys, to arrange girls, how many different positions are remaining? So the previous example I said we have 6 different places, so that is over. Now in a row, so I am not specifying how many positions are available, I just said a row. Now first you arrange boys. Number of ways in which 3 boys can be arranged in a row, 3 factorial. Now my condition is no 2 girls sit together. If no 2 girls have to sit together, my question is, how do you arrange girls after you have arranged boys, right? So first you need to count between boys how many positions are available, correct? So between boys, this position, this position, this position, this position. So for any arrangement you see between boys, remember the word when I say between, it's not exactly between the position before the first boy, the position after the last boy is also counted. So to arrange girls, guys, now you have not 3 but 4 positions, because we are not specifying there are only 6 chairs, we are just saying that in a row. So now that after arranging 3 boys, which can be done in 3 factorial ways, now you have 4 positions available for girls, and now you have 3 girls to be seated in those 4 positions. So number of ways in which 3 girls can be seated in 4 positions is 4p3. So you ask me what is 4p3? If you try to calculate the value of 4p3, which is 4 factorial by 4 minus 3 whole factorial, which is 4 factorial by 1 factorial, you will get 24 different ways in which girls can be arranged after you arrange boys. Now you might be wondering, let us say in this case only, let me put G1, G2, G3, correct? This is one way. Or you can choose not to fill the first position and you can fill second, third and fourth. Or you can choose to fill the first position, the second position which I have underlined, and you may choose to fill the last position. So you might be asking, sir, in this case the boys are sitting together. If I observe this, because this position is not occupied, the boys are sitting together. I have no issues, because I only told you that girls cannot sit together, right? So when I say girls cannot sit together, you should not assume that boys also should not sit together. First you arrange boys, in between the boys, that means the first position, the last position also count, and see how many ways you can arrange the girls. Now you will get 3 factorial into 4p3. Understood? So this answer effectively becomes 3 factorial is 6, 4p3 is 4 factorial, which is 24. You will end up getting the value as 144. Guys, using the same example, let me proceed and ask you a very interesting question. How many ways can you arrange 3 boys and 3 girls in a row such that no two boys and girls sit together. Now you are thinking where I am coming from. Now I don't want boys to sit together, neither do I want girls also to sit together, right? So how do you start this question? It's fundamentally the same approach, but you have to be very careful. I don't want boys and girls, no two boy and girls to sit together. I have to arrange all of them. Now my first question is, should I start by arranging boys or should I start arranging with girls? What is your approach in this case? Correct? So you try to first arrange using boys. Okay, B1, B2, B3 and all the different combinations that we have written before. So effectively it is 3 factorial, which is 6. Guys, now please understand, if you now want to arrange girls, you cannot choose to leave a place between the boys as empty, or in other words, you can fill this one, this one, this one of these 3, or you have to fill this one and this one, correct? So there should not be any gap between any two boys and there should not be any gap between any two girls. So if you understand this logic, if I start the arrangement with boys, which is boy, 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 then I can fill the girls also in only 3 places. So effectively it will become 3 factorial into 3 factorial, which is 36. But since I did not specify you to only start with a boy, you can say, sir, since boys and girls should not sit together, the arrangement can also start with a girl. You are equally correct. You can start by first arranging girls, which is 3 factorial. Then you can arrange boys in another 3 factorial, which is again 36. So your total answer becomes 72, because these two are independent cases. Now you understand? So when I multiply 3 factorial into 3 factorial, I am using multiplication rule. When I am adding 36 with 36, I am using addition rule, because these two are independent cases. Now you understand what is the difference between no two girls sitting together, no two boys sitting together, and no two boys and girls sitting together, right? I hope this example will give you good clarity to proceed when we do the next set of questions from your exercise.